from 3.1, we are just looking at derivatives, basically, right? So just the differentiation rules, finding the equation of the tangent line. Let me see what you see so I can control that. Okay, so find the equation of the tangent line to the graph. Like, for example, just anything from here, just a simple, you know, you've seen the previous test roughly, so you will have some functions to differentiate. So then I can give a problem like, let's say, 35 on 182. Given function, find the equation of the tangent line and the normal line. What else from here? Just find
just for considerators, like a normal line is the line that's perpendicular
to a point on the graph, but it's also perpendicular to the tangent.
Okay.
Yes. Yeah, we can look at a problem like that. Something like nothing that we did not cover in class, in you know, general. So we had find the second degree polynomial. We did that. I remember something like this. Sketch the graph of the function and function inverse. At what numbers is the following function differentiable? So that's pretty much it from here. Then the product and quotient rules, obviously, the same idea. Maybe a graph in which you have to determine, let's say, u prime of 1, and you're given a graph. Maybe a situation like this, in which it's 52, in which you are asked to find the derivative of that function. That's pretty much it here, nothing else. Derivatives of trig functions. All 6 trig functions with their derivatives, and these limits that we worked on a lot. So again, we can go back and look at those limits again. Then the chain rule, all these type of functions to differentiate that have their function composition, any of these you would like to choose, I'll be more than happy to work on. Something like this with a table, reading from a table like we did in class, again from the graph, and just some examples. We had, I think we did this one with a rumor or something, just to see how it's applied in real life situations. The implicit differentiation, again, just examples with implicit differentiation. We had an example yesterday with a hyperbola. So then differentiating the inverse functions, but only 3. Sine inverse, cosine inverse, and tangent inverse. Then derivatives of log functions and logarithmic differentiation. You will definitely have a problem in which you will have to differentiate a function raised to another function, and you know there is no rule for that. And we practice some natural log. Okay, 3.7, just what we had, the cost function and the marginal cost, the particle problem with all those questions. Motion problem that we did in class, like 9 or 10 or 7, with the velocity and acceleration. We also looked at the volume of a tank. I remember doing that problem. We did not cover 3.8. It's part of pre-calc. And then related rates. I think we had, I don't know, maybe 10 problems already. The cone problem. The particle moving along a curve, the angle problem, the resistor problem at the bottom of page 249, and linear approximations. So we just looked at a problem actually in which an approximation we were asked to determine the x values close to 0 that make the approximation within such and such. Derek, did you put the parentheses or brackets in that problem?
In parentheses.
Okay, and it took it with parentheses?
Yes.
Okay, excellent. Thank you. Okay, and the last section, only 3, not the inverse hyperbolic, just nothing about the inverse hyperbolic. If I put a problem, which I will not, I will give it a formula. So all I want you to remember is that the derivative of so how did they? So how did was the answer at most? No, it was not at most. With at most, they would have asked the brackets, right?
Accurate to within.
Okay. So within, so that requires. So it's not. It doesn't say the error is at most, because at most it includes 0.1. You use brackets. But if it says within, we have to use parentheses. Okay, I just wanted to clarify it for everyone else. Thank you. So just these 3 functions, hyperbolic functions, and differentiation, nothing else. There is nothing else. I'm anxious. Thank you. I'm anxious to start. Chapter 4, because in chapter 4, once we get to, so we do have a good start because we did L'Hopital's rule. So that was done already. We're using it as we speak. So once we get to 4.4, it's going to be okay. And then we have maximization, optimization, max-min. This is a huge topic of math. Huge branch of math. It's all related on, is based on calculus. The antiderivatives would be with chapter 5. So we have finally Newton's method. So that's Newton's method that we are going to talk about. So it's not going to take more than 2 weeks, but I need to also to review it. So, okay, is that good enough, Mason?
Yeah, that's totally fine.
Okay.
I just kind of wanted to get a glimpse on, you know, what to expect besides like looking at the
Yes. Yes. Very good. What do we continue with? Anything?
Let's see. Did we go over from the practice test part G?
Let me look. Part G. In 1, you mean 1G?
Yeah.
Yes, I think so. But if you need it again, we can.
No, I think I'm okay. I just wasn't sure.
I don't know if we did 1C. Did we do 1C?
Yeah, we did 1C.
Okay. Anything?
I was seeing the G.
Okay, do you want me to choose other problems?
Sure.
Or do you have something in mind?
Do you think we could do
yes.
1H?
From the test?
I'm sorry, yes.
Yes. Yes, so that is y equals 2x minus 5 to the third, everything divided by 3x plus 4 to the fourth power. This is extremely important for chapter 4, because you're going to see what we do with this there. So we're asked to find y prime. You can change it into a product, but in this case, I would not recommend that. So let's keep it as a ratio. When I differentiate a ratio, the denominator has to be squared. And I differentiate the numerator, 3, 2x minus 5 squared times 2 times the denominator, and minus I copy 2x minus 5. Watch me run out of room, sorry. Multiply by 4 times 3x plus 4 to the third power times the inner function prime, which is 3. So then I will rearrange it because it's all over the place. I don't like the way it looks. So let me just rewrite it. So this is 6, 2x minus 5 squared, 3x plus 4 to the fourth, minus 12, 2x minus 5 to the third, and 3x plus 4 to the third. Everything over 3x plus 4 to the 8th power. So then, at this point, I will factor out the maximum possible. So 3, 4, 5. Sorry about that. Okay, so I will factor out 6. I will factor out 2x minus 5 to the second power. And I will factor out 3x plus 4 to the third. So let's see what is left. 6 is out. These are completely out. From 4, I took 3 out, but there is one of them is still in there. I reached this stage when I copied the negative sign. From 12, I took 6 out, so there is a 2 left. From these 3, I took 2 out, so there is still a 2x minus 5 left inside. And this is completely out. Only now I can do this. Not before. So then I copy 6, 2x minus 5 squared, 3x minus 4x, negative x, and 4 plus 10, 14. And yes, I will factor out negative 1. Again, you will see in chapter 4 why this is so important. And this is it.
It would be wrong to distribute the 6 into the 2x minus 5?
You can. You have to square it if you want to distribute it. Because this is power. So by the order of operations, I have to square first and then multiply by 6. If you want to put it in, you have to square 36 and then distribute it. But we don't want any factors in there. We want as simple as possible, and all completely factored.
Okay, thank you.
Yes, thank you. Good. Next question. Anything else you would like to work on? You have anything in mind? What about a linear approximation? Will that be something you are interested in now, or you want something else?
Yeah.
Okay, so page 255. I'm going to pick 26, but you can look at that and say if you want 26 or anything else. Is 26 okay, or you want a different one?
Yeah, that's fine.
So 1 over 4.002. Okay, very good. So remember, I always, I don't want you to memorize this, but we established the fact that delta y, the exact change in the function for a change in x, is approximately not equal to the differential of the function, which is not the derivative. This is the exact, and this is the differential, which is obtained with the derivative. So the left-hand side, the exact, will be f of x plus or minus that change minus the original f of x is approximately, and please remember, do not confuse this with the derivative. So this is f prime of x times dx. And of course, I'm going to move f of x. So f of x plus the error in x is approximately f of x plus f prime of x dx. Having said this, I know that this must be this piece. This left-hand side is 1 over 4.002. So once I determine the function x and dx, I can fill it in. I can fill these pieces in and I'm done. So what will be the function? What will be x? What will be dx? And of course, f prime of x. Once I determine these values, I'm done, pretty much. The problem is solved.
Would be the f of x would be 1 over x.
Absolutely. You caught me. Get a sip of water. Absolutely. So f of x is 1 over x. And please remember, please try to remember that f prime for this is
it would be negative 1 over x squared.
Excellent, all of you. Excellent. Thank you for taking my advice. I was just thinking, can anyone text Omari? Because I only saw him like last week. So if anyone can do that for me, it would be great. Okay, sorry about that. So what about x? And what about dx? Remember, dx must be an error, must be tiny, and x is x.
X be equal to 4 and dx be equal to 0.002.
Perfect. So all I have to do is just punch it in, put them in the correct place. That's all I need to do next. So then I will copy 1 over 4.002, and that's approximately f of x. This is f of x with x in it will be 1/4. This will be minus 1 over, and with x in it will be 16. And dx is 0.002. Yes, I will try to simplify it a little bit. So now this I can write equals. Here, between these two sides, I cannot write the equal symbol. But now I can write the equal symbol. So it's 1 over 4 minus, I'm going to put a 4 up here, 0.002 divided by 16. I'm finding the least common denominator to be 16. And I have 4 minus 0.002, which will be 3.998. We don't like decimal numbers in a fraction, so I'm going to multiply top and bottom by 1,000. So 3998 over 16000. And then I can simplify this as much as I can. Let's see, 3998. Can I divide it by 4? No. So I can only divide it by 2. So all I get is 1999 divided by 8,000. So therefore, I still would like to, I don't have to do anything else. This is done. It says that 1 divided by 4.002 can be approximated by this number. But of course, I'm going to check and make sure that my numbers are correct. So 1999 divided by 8,000. And 1 divided by 4.002, they have to be very close. They have to be very close because dx is very tiny. And it's the correct answer is 0.249875, and I have an accuracy of 6 digits. It's more than I need. Good. So that was approximating a function value, when x is 4.002, in other words, approximating it using differentials. So this is the differential of y, and this is the differential of x. This is the differential of x. You're going to use this in Calc 2 in series again, so this is a very important relationship. Yes?
Can you just that piece of paper right there for a sec?
Yes, of course.
Oh, no, the top one. Just so I can see that equation again. Right, yeah, perfect.
Better?
Yeah, thank you.
Okay. Next question. What else you would like to go back to?
Can we do another one of those?
Yes. Another approximation like that?
Yeah.
Would you like to choose page 255 or?
There's actually one on a website.
Yes?
It's, so it's...
May I remove this now?
Yeah, thank you.
Sure.
So it's f of x is equal to x to the 2/3 power. And then a is equal to 27.
27?
Mm-hmm.
So they want the linear approximation for this one.
Yes.
Okay. So the linear approximation is exactly what you just saw here. Just different notation.
Okay.
So exactly everything you see. So it's f of a plus f prime of a. And this one is the difference between x and a. Still the same thing, dx. So I have to determine f of a. I have to determine f prime of a, and then put all pieces together. What does this say? Okay, what does this say? So let's suppose this is the graph of f of x, and let's suppose that this is a. It only says that near a, near 27, if I use the equation of the tangent, or I use the function itself to evaluate near a. So if this is 27, I'm talking about 26.9 or 26.8 or something close. If I use the tangent or I use the function, I will not make a huge error. They're very, very close. But as long as I pick a close, values close to a, not here. Mm-hmm. Here I can use a different tangent and do the same thing, but not this one. It's too far away. That's all it means. Okay, so f of a, so f of 27, you can use the calculator, but here's what I would have done. Change 27 into 3 to the 3rd and put power 2/3 on it. And then when I multiply, these two go away, so it's 3 squared, which is 9. Yes, okay, if you're in a test situation, you want to get this quickly, yes, here's what I would do. I would put 27 caret in parentheses 2/3, and I would have to get the exact same number.
Wow.
But it's easier because I saw the denominator being 3. I saw the 27 is 3 to the 3rd, and when I multiply the powers, these two go away, so I have 3 squared, which is 9.
Gotcha.
It's up to you. Okay, so now we have this. Now I have to find f prime. F prime of a, I bring down 2/3 times x, but I subtract 1 from 2/3, and that will give us negative 1/3. So this will basically be 2/3 the cube root of x. I'm not removing it, I'm just sliding it. And again, I'm sorry, this is just x first, sorry. So now, f prime of a, when I plug in 27, the cube root of 27 is 3. 3 times 3 is 9, so this will be 2/9. So I have this as 9, I have this as 2/9, and I have this as x minus 27. And I will get the equation of a line. Which line? This one.
Right. And you plug 27 into that f prime of x, correct?
Yes, yes, because that's what we have. Because it's f prime of a. So
Gotcha.
first I found f prime of x to get this. And then I plug in 27 to get 2/9.
Cool. Okay.
So finally we put everything together, and this is the linearization of the function. So that will be 9, and then plus 2/9, and then x minus 27. I have to clean it up, and I have to give the line. So this will be 2/9x, but minus, when I simplify by 9, I get 3 times 2 is 6, and plus 9. So finally, L of x is 2/9x plus 3. Again, what does this mean? This approximates f of x, which is x to 2/3, near 27. So if you have something close to 27, if you use this or use this, you're not going to make a big error. You will make an error, but it's not going to be big. So every function can be approximated with a line. Any function can be approximated with a line near a number. Because this depends on 27. If I change 27 into 5, this will be totally different. Approximating x to 2/3 near 5 will look totally different. It will still be a line, but a different line with a different slope.
Okay, cool.
Better?
Yeah, a lot better. Thank you.
Thank you. Good. Next question. Okay, I'm looking at the problem unless you have something for me.
Oh, what page?
266, I'm going to write that. At what point on the curve y equals is the tangent horizontal? Is that okay?
Yeah, that works.
Okay, 83 on page 266. Okay, 10 minutes. Okay, we have time for this and maybe one more, and then I'll open another meeting. So we have y equals natural log of x plus 4. The function is squared. Has a horizontal tangent. So at what point on this curve there is a horizontal tangent? What does that mean, horizontal tangent?
Y equals 0.
Exactly. So the slope equals 0. Y prime equals 0, right? So at this point, there is a horizontal tangent. F prime is 0. At this point, there is a horizontal tangent. F prime is 0. So we're really looking for potential max min. Good. So then, in order to solve this equation, which we will solve a lot in chapter 4, I have to find the derivative. So y prime equals, this is a function. So how many functions I see here? The power function is number 1, natural log is number 2, and x plus 4 is number 3. And I start with the outermost. Bring 2 down, and then natural log of x plus 4 raised to 2 minus 1, but that's 1, times the inner function prime, which luckily is 1. Times natural log, which is times 1 over x plus 4, times the inner function, which is 1. So, one more time. We differentiate 2 times 2 to natural log 2 minus 1 times the inner function, that's number 2. The inner function prime is 1 over x plus 4. And then finally, function number 3, prime is 1. So we want to set this equal to 0. 2 natural log of x plus 4 over x plus 4 equals 0. Then 2 will never be 0. X plus 4 cannot be 0. Of course, it will be undefined. So what equation do I need to solve from here? I'm getting some water. How do I solve this equation? What do I have to write? Of course, there is no need to even look at 2. A fraction is 0 only when?
The numerator is 0.
Very good. So the natural log of x plus 4 equals 0. And there is only one number that we apply natural log to get 0. Or you can say e raised to 0 equals this. But how much is e raised to 0?
1.
That's it. So then x plus 4 must equal 1, which makes x equals 3. So at x equals 3, it says at what point? So that's not enough. We are asked to present the point. So the point, let's say point P has 3 comma. When I have to determine this as f of 3, which will be 3 plus 4 is 7, natural log 7 everything squared. I wouldn't bother. I would just write it as negative natural log 7 squared because it will not be, it would be an irrational number.
It'd be better to write it like this in like a testing scenario.
Yeah, or just natural log squared like this. Yeah, I wouldn't bother. Now, if it's a word problem, I will not tell you that I have in my pocket natural log 7 squared money, right? Dollars. So, but it's an abstract situation, so you wouldn't need to do anything else. Yep. I think we have 5 minutes left, so let's try another. Do you have anything in mind, or I will choose? Anything? Do I choose then?
Yeah, you can choose.
Okay, find an equation of the tangent to the curve that is parallel to this line.
Perfect.
Okay. So this is 84 on the same page. 266. Find equation to the tangent to the curve. So this is y equals e to the x. Parallel to the line to x minus 4y equals 1. Yes. Okay. So first of all, if this is e to the x, which I'm not really graphing anything, I just give you the idea. So we want to find the equation of the tangent line to the graph of this that is parallel to that. So assuming that this line looks like this, it doesn't matter. I'm just creating the scenario. And parallel to it, there must be a tangent to the graph of e to the x. They want us to find the equation of this line. Knowing that these two lines are parallel, we know that they must have
Same slope.
Same slope. So if I call this M1 and if I call this M2, M1 must equal M2. But can I find M2? And the answer is
yes.
Yes. So I have x minus 4y equals 1. And I will solve for... somebody told me that red is not a good color. Can you see the red or not?
Yeah.
Oh, okay. So I have to solve for y. I have to present it like this. Only when I present the line in the form of slope-intercept form, then I can identify the slope. As it is right now, I cannot. So I will solve for y, and the coefficient that I will end up having in front of x will be the slope. So then negative 4y equals negative x plus 1. Do not write a long fraction and put negative 4 underneath. You have to divide each and every term by negative 4. So negative 4y times divided by negative 4 is y. Negative 1 divided by negative 4 is 1/4 x. And 1 divided by negative 4 is negative 1/4. Now I know m2. How much is m2?
1/4 x.
No x, right?
Oh, sorry.
Just 1/4. Very good. So then I know that m1 is 1/4. Is also 1/4. But this must equal f prime. So without determining this point where the tangent is 1/4, I will not be able to find the equation of the line. So for now, I only know that the slope is 1/4, but I need to find this point. Why? Once I have that point, I will have y minus y1 equals the slope times x minus x1, which is the point slope form. I'm not removing it, I'm just sliding it because you can see it. In which I have 1/4, but I don't have x1 and y1. So then I have to solve this equation. But how much is f prime? F is e to the x. So what will this be?
So it would just be e to the x.
Yes.
Right?
Yes. So e to the x equals 1/4. But I have to solve for x because I need this value. And then I will get this value. How do I solve this equation for x, and what type of equation is it?
Natural log.
Very good. We have to apply natural log to both sides. Perfect. So I bring x, natural log e is?
1.
Very good.
Oh, wait. Yeah.
Very good.
Is it?
Yes?
Okay.
Natural log of 1/4, which can be written as negative natural log 4. Why? Because this is the same with natural log of 4 raised to negative 1, and I can put the power in front. So this is the same thing with that.